Hello, science fans. Today we're going to explore something so small it's almost impossible to imagine, but it's changing our world in huge ways. We're talking about nanotechnology. Now, nano might sound like a funny word, but it comes from a Greek word meaning dwarf. And that's a perfect description, because nanotechnology is the science of building and working with things on a super tiny scale. This scale is called the nanoscale, and it is measured in units called nanometers. It's a world where we can control individual atoms and molecules, the very building blocks of everything around us. Consider this. So, just how small is a nanometer? Let's put it into perspective. Take a single sheet of paper from your notebook. It feels pretty thin, right? Well, that one sheet of paper is about 75,000 nanometers thick. Now look at a single strand of your hair. It's even thinner, but it's still enormous in the nanoverse, measuring around 50,000 nanometers across. If you could shrink a football down to the size of just 1 nanometer, a tiny virus would be as big as a grown-up person standing next to it. That's an incredible difference in size. Working at this level is like having a toolkit for atoms. This isn't just about making things smaller for the sake of it. When we get down to the nanoscale, the rules of the game change completely. The familiar properties of materials, like their color, strength, or ability to conduct electricity, can become totally different. It's a place where the weird and wonderful world of quantum physics takes over. This means that by simply changing the size of a material's particles, we can change how it behaves. For example, a chunk of gold is, well, gold-colored. But if you break that gold down into tiny nanoparticles, it can appear red or even purple. Understanding this allows scientists to engineer materials with brand new abilities. Think of it like using the same set of Lego bricks to build a car one day and a spaceship the next. By rearranging the atoms and changing the size of the structures, we can create materials that are stronger, lighter, and more efficient than anything we've had before. This ability to fine-tune the properties of matter is the core principle behind the nanotechnology revolution. It's about building better things from the bottom up, one atom at a time. It's a whole new frontier of science and engineering. So, why does matter act so differently at the nanoscale? It all comes down to two main ideas: more surface area and quantum effects. First, let's talk about surface area. Imagine you have a big cube of sugar. It has 6 sides. If you smash that cube into thousands of tiny sugar crystals, you still have the same amount of sugar, but you've created thousands of new surfaces. Tiny nanoparticles have a huge surface area compared to their volume. This makes them much more reactive chemically. This increased reactivity is super useful for things like catalysts, which speed up chemical reactions, making industrial processes more efficient and less wasteful. The other reason things get exciting is because of quantum effects. This is a fancy term for how matter and energy behave at the atomic and subatomic level, which is very different from our everyday world. In the nanoverse, particles can be in multiple places at once, and their properties, like electrical conductivity or magnetism, are directly tied to their size. This is not something you see with a baseball or a bicycle. Scientists can use these quantum effects to create materials with specific tailored characteristics. By controlling the size of a nanoparticle, they can control its properties. It's like having a dial to tune a material to do exactly what you want. This control allows us to build amazing new things. For instance, sawa awing shuwas were based to pawas adventurshats so deteng creden beng wine suffersin bar pongwai carbon nanotubes, which are basically rolled up sheets of carbon atoms just 1 nanometer thick, to other materials. We can make them incredibly strong yet surprisingly lightweight. These materials are being used to build lighter airplanes and spacecraft, which saves a lot of fuel and makes travel more efficient. It also helps in making stronger, more durable sports equipment like tennis rackets and bicycle frames. We are literally re-engineering the world around us by controlling its smallest components. It's a powerful concept with limitless possibilities for innovation. This ability to manipulate matter at its most fundamental level is what makes nanotechnology a true revolution. We are no longer limited by the natural properties of the materials we find. Instead, we can become architects of matter itself. We can design materials to absorb more light, repel water more effectively, or conduct electricity with zero resistance. The technology works by giving us a precise toolkit to build with atoms and molecules, opening up a world of custom-designed materials that can solve some of our biggest challenges in energy, medicine, and manufacturing. The possibilities are truly as vast as our imagination. You might be surprised to learn that you probably already use nanotechnology every single day. Take a look at the computer or smartphone you're using. Nanotechnology is the reason these devices have become so powerful and so small. The tiny switches inside computer chips called transistors have been shrinking for decades thanks to nanotechnology. In the year 2000, a typical transistor was about 250 nanometers wide. Today, they can be just a few nanometers across. This miniaturization allows us to pack billions of transistors onto a single chip, giving us incredible processing power and memory in the palm of our hand. The field of medicine is another area where nanotechnology is making a huge impact. This is a field called nanomedicine. Imagine tiny microscopic robots or nanobots that could travel through your bloodstream to find and destroy cancer cells without harming the healthy cells around them. This isn't science fiction, it's a real area of research. Scientists are developing nanoparticles that can carry medicine and deliver it directly to a diseased area. This targeted delivery makes treatments like chemotherapy much more effective and reduces harmful side effects. Nanotechnology is also improving medical imaging, using tiny particles called quantum dots to light up tumors so doctors can see them more clearly. Nanotechnology is also helping us protect our planet. Scientists are using it to tackle big environmental problems like pollution. For example, tiny nanoparticles can be used to clean up contaminated water. Some nanoparticles can bind to and remove heavy metals like arsenic from groundwater, making it safe to drink. Others are being developed to break down pollutants into harmless substances. Nanotechnology also helps us conserve resources. Special nanocoatings can make surfaces super slippery, preventing ice from building up on airplane wings or windmills, which saves energy. Even simple things like paper towels can be made with nanotechnology to absorb 20 times their weight. Look around you and you'll find other examples. Many eyeglasses and camera lenses have an ultra-thin nanofilm that makes them scratch-resistant, anti-reflective, and water-repellent. Some sunscreens use nanoparticles of zinc oxide or titanium dioxide. Because the particles are so small, they don't leave a white film on your skin, but they still provide excellent protection from the sun's harmful UV rays. From the clothes we wear to the cars we drive, nanotechnology is quietly working behind the scenes to make products better, smarter, and more sustainable. It's a tiny technology that is already having a massive effect on our lives. While the future of nanotechnology is incredibly exciting, it's not without its challenges. Whenever we create something new, we have to think carefully about its impact. One of the biggest questions scientists are working on is safety. Since nanoparticles are so small, they can potentially get into parts of the body or the environment where larger particles can't. Researchers are studying how these tiny materials interact with living cells and ecosystems to make sure they are safe for people and the planet. We need to understand the full life cycle of these materials, from how they're made to what happens when we're done with them. Another hurdle is the cost and environmental impact of making nanomaterials. Producing some of these advanced materials can require a lot of energy, water, and sometimes harsh chemicals. This could create its own set of environmental problems. However, scientists are always innovating. For example, they found ways to create useful quantum dots using simple green tea leaf extract, a method that is cheap, non-toxic, and much better for the environment. Finding sustainable and affordable ways to manufacture nanomaterials on a large scale is a key challenge that must be solved for the technology to reach its full potential. Despite these challenges, the future looks bright and very, very small. Imagine a world where nanobots inside our bodies act like a personal team of doctors, constantly monitoring our health and fixing problems before we even feel sick. Think about ultra-efficient solar panels, made with nanomaterials, that could power our entire world with clean energy. Or computers that boot up instantly because their memory is built with nanoscale magnets. These are the kinds of breakthroughs that nanotechnology could make possible in the coming decades. We are just scratching the surface of what this powerful technology can do. In the end, nanotechnology is more than just a field of science. It's a new way of building our world. By learning to control matter at the atomic level, we're unlocking a universe of possibilities. It will help us create smarter computers, more effective medicines, and a cleaner environment. The journey will have its obstacles, but the potential rewards are immense. The tiny tech revolution is here, and it promises to reshape our future in ways we are only just beginning to comprehend. So keep asking questions, keep exploring, and get ready for a future that is built, one tiny atom at a time. Consider this.